Welcome, ladies and gentlemen. So what I have in this case is secant of theta equals 7. And what I'm going to do is show you how to use an acute triangle to be able to evaluate for all 6 trigonometric functions. So we're going to go and draw a nice little lovely acute triangle. And we'll just name an angle here theta, and we'll make a 90-degree angle. Now, according to this theta, we know that this is my hypotenuse, this will be my adjacent side, and this is going to be my opposite side. So then I need to go back and look at my secant function and say, all right, well, what does secant again represent? Well, to do that, let's go back to cosine. Because usually by learning secant, you first learned about the cosine function. We know that the cosine of an angle represents the ratio of the adjacent side over the hypotenuse. So therefore, secant is the reciprocal of that, which is the hypotenuse over the adjacent. Now, it sometimes comes into trouble when students say, well, that's a whole number, though. So how do we rewrite that as a fraction? Well, remember, we can take all whole numbers and put them over 1. So therefore, I know that now my hypotenuse has a measurement of 7. And my adjacent side has a measurement of 1. So now all I need to do is find the value of the opposite side to evaluate for the rest of my trig functions. So to do that, I'll use the Pythagorean theorem. Now remember, the Pythagorean theorem really says leg squared plus leg squared equals c squared, where c is going to represent our hypotenuse, and our adjacent and our opposite are going to be our 2 legs. So it doesn't really matter which one is a and b. We just need to make sure we're taking our 2 legs. Now we don't have the opposite side, so I'm going to use it as a variable, and I'll just make it b. It doesn't really matter. You could make it a and then have that b, but we just want to use it as a variable. So I'll say a is 1 plus b squared equals c squared, which is 7. Okay, so therefore I have 1 squared plus b squared equals 49 minus 1 minus 1. B squared equals 48. Now I take the square root of both sides. So I have b equals the plus or minus the square root of 48. And we're going to want to see if we can simplify that. So we want to look into, what square numbers divide into that. And I think the highest square number that I see is 16. And 16 goes into there 3 times. So therefore, I can rewrite this as 16 times 3. And now I can take the square root of 16, which would be 4. So it's plus or minus 4 square root of 3. And that's very good. All right? But now we look at this. So therefore, this side's going to be 4 square root of 3. But why are we doing plus or minus? Well, in this case, we're just in these types of problems, we're only going to be dealing with this acute triangle in the first quadrant. So we're just going to deal with the positive. We will get to later when we're going to use the positive and the negative, but that's going to be dealing with what we get with constraints. So I'll get to those types of problems in another section. So it's going to be positive square root of 4 over 3. So now we need to determine, all right, well, then what is the sine? What's the cosine? And what's the tangent? We want to figure out those first before we get to our reciprocal functions. So the sine, remember, is adjacent over hypotenuse. So I go over my triangle and I look, why don't we write this in red so then it kind of looks like the rest of them, huh? That sounds like a good idea. 4 square root of 3. OK. So the adjacent over the hypotenuse, that's just going to equal 4 times square root of 3 over my hypotenuse, which is 7. I can't simplify that any further, so that's it. Cosine, again, remember, is adjacent. What am I doing? This opposite over hypotenuse. Jeez, the opposite side is what I just said, 4 times square root of 3 over 2. The cosine is the adjacent over the hypotenuse. I think I'm losing my brain here, which is 1 over 7. And the tangent is going to be opposite over adjacent. So that's going to be 4 over square root of 3 divided by 1, which just equals 4 square root of 3. All right, so now what I'm going to do in the red, I'm going to do the reciprocal functions. Now remember, the reciprocal functions are just the reciprocal of each one of these. So we have cosecant of theta, which is just a reciprocal of opposite over hypotenuse. So that's going to be hypotenuse over opposite. And that's just going to equal 2 over, where am I getting 4 over 7? What is wrong with me? So that's going to be 7 is your hypotenuse, right? Sorry. So I have hypotenuse, which is 7, not 2, over my opposite side, which is 4 square root of 3. Well, ladies and gentlemen, I need to make sure I rationalize my denominator. So to do that, I need to multiply by square root of 3 over square root of 3. Then my final answer is going to equal 7 square root of 3 over square root of 3 times square root of 3 is 3. 3 times 7, 3 times 4 is 12. All right, so now let's move away from cosecant. That's just giving me problems. Let's go to secant. Secant is the reciprocal of adjacent over hypotenuse. So that's going to be hypotenuse over adjacent. So I look at my hypotenuse, which again is 7, over my adjacent side, which is 1. All right, well, this one's a pretty nice answer, right? We can just simplify this to 7. All right, and then look at tangent, which is opposite over adjacent. So therefore, cotangent, which is the reciprocal function, is going to be adjacent over opposite. So when doing adjacent over opposite, what I have here is I'm just going to have to do 1 over 4 times the square root of 3. Now again, just like how we did for cosecant, I need to make sure I rationalize the denominator. So I'll multiply by the square root of 3 over 3. So therefore, my final answer is the square root of 3 over square root of 3 times square root of 3 is 3. 3 times 4 is 12. So there you go, ladies and gentlemen. That is how you find all 6 trigonometric functions when given one value by using an acute right triangle. Thanks.